The silent void of space hides unimaginable terrors. We often gaze at the stars and see beauty, but the cosmos is also home to forces that are genuinely terrifying on a scale we can barely comprehend. By the end of this journey, you will know the 25 most frightening phenomena lurking in the darkness. We will encounter worlds cast adrift from their suns and stars that feast upon their neighbors. What cosmic mystery sends a chill down your spine just thinking about it? Out in the cold, empty stretches between stars, entire worlds wander alone. These are rogue planets, celestial orphans flung from their home solar systems by gravitational chaos. They travel the galaxy in perpetual night, untethered from any sun. Imagine a world like Earth, but one where the sun never rises, where the only light comes from distant, unmoving stars. These planets are not just theoretical. Astronomers estimate billions might be drifting through our Milky Way, invisible to our telescopes because they emit no light of their own. One could be passing through our solar system right now, a dark ghost in our own celestial neighborhood, and we might not know until it was already upon us. The sheer scale of this unseen population is a chilling thought. A close encounter with one of these drifting worlds would be catastrophic. Its gravitational pull would be immense, enough to disrupt the delicate orbital dance of our solar system. It could send asteroids careening toward the inner planets, or worse, tug Earth itself out of its stable, life-giving orbit around the Sun. We would either be flung into the deep freeze of outer space or pulled into a fiery death spiral. And what would these rogue worlds be like? Some could be Earth-sized or even larger, shrouded in thick, poisonous atmospheres or covered in global oceans frozen solid into ice as hard as steel. Their surfaces would be the most alien landscapes imaginable, shaped by forces we can scarcely comprehend, dark and silent for eons. The idea that such an unpredictable, frozen leviathan could be drifting unseen toward us is a profound and humbling cosmic fear. And this is just the first of our terrors, a lonely world in the dark. But the darkness of a rogue planet is nothing compared to the absolute void of a black hole. These are not merely empty spaces, they are cosmic traps from which nothing, not even a single photon of light, can ever return. A black hole is a region where matter has been crushed into an infinitesimally small point, a singularity, creating a gravitational pull so overwhelming that the very fabric of space and time surrenders to it. The boundary marking this point of no return is called the event horizon. Crossing it is a one-way trip, a journey into a reality where the laws of physics as we know them cease to exist. To approach a black hole is to face a fate more bizarre and gruesome than any science fiction. The part of you that ventured closer to the hole would feel a vastly stronger gravitational pull than your feet. This difference in force, the tidal force, would stretch you out. You would not simply be crushed. You would be pulled into a long, thin strand of atoms, a process scientists call spaghettification. You would become a human stream of particles spiraling into the infinite density at the center. It is a death that defies all earthly comprehension, a fundamental unraveling of your very form. The true terror, however, lies in the scale. Lurking at the heart of our own Milky Way galaxy is a monster named Sagittarius, a star. This is a supermassive black hole with a mass millions of times that of our Sun. It is not a lonely predator, but the silent, gravitational king around which our entire galaxy dances. Every star, including our own Sun, orbits this invisible behemoth. While it is stable now, a sudden disturbance could, in theory, awaken its appetite. It could begin to feast, pulling in entire star systems, shredding them into a glowing, incandescent disk of superheated gas and dust called an accretion disk before swallowing them whole into that final darkness. This is the ultimate cosmic power, a drain in the fabric of the universe that could erase our entire existence without a trace. And yet, even this gravitational leviathan is not the only way the universe conspires to erase worlds. Even a supermassive black hole consumes matter at a relatively leisurely pace, a slow cosmic digestion. But the universe possesses a weapon of instantaneous, total annihilation. The most violent explosions since the birth of the cosmos are gamma-ray bursts. In just a few seconds, a single burst can release more energy than our Sun will emit across its entire 10 billion-year lifetime. It is a flash of pure, concentrated fury that can outshine entire galaxies. These events are categorized by their duration. Long gamma-ray bursts last for a couple of minutes and are thought to be the death cries of exceptionally massive, rapidly spinning stars as they collapse into black holes. Short bursts lasting less than 2 seconds are the even more violent result of two ultra-dense stellar corpses, neutron stars, spiraling into each other and merging. Both scenarios create focused jets of the highest energy radiation, beams of destruction that lance across the universe at the speed of light. The true terror lies in the aim of those beams. If a nearby gamma-ray burst, one within a few thousand light-years, were to point its deadly jet directly at Earth, the consequences would be an extinction-level event unparalleled in our planet's history. The first sign would be a flash of light brighter than any star, visible even in the daytime. But this light would be the least of our worries. The incoming radiation would begin to chemically tear apart our atmosphere. It would shred the ozone layer that protects us from the sun's ultraviolet rays, effectively removing our planetary sunscreen. The sky would then rain down nitric acid, a toxic downpour poisoning the land and sea. The initial blast of radiation would bathe the surface of the planet, causing immediate radiation sickness for any life exposed and triggering widespread fires. The aftermath would be a global winter as the damaged atmosphere blocks sunlight, collapsing the food chain and leading to a mass extinction. It is believed such an event may have been responsible for one of the great die-offs in Earth's distant past. While the odds of a nearby star aligning its death throes with us are astronomically low, they are not zero. This is not just a theoretical fear. Astronomers constantly monitor the sky for these flashes, a silent early warning system against a threat that could arrive without any other signal. The knowledge that such a cosmic gun exists and that we are floating in its potential line of fire adds a constant, silent tension to our place in the cosmos. And if the sheer power of a gamma-ray burst is not unsettling enough, consider a force that does not merely destroy, but erases the very laws that hold reality together. Gamma-ray bursts are a flash of destruction, but they leave the universe itself intact. A far deeper terror awaits in the foundations of reality. Our universe might not be in its most stable state. What we perceive as empty space, the vacuum, could be a fragile illusion, a valley in a cosmic landscape of possibilities. Physicists call this a false vacuum. It is stable for now, but a more stable, a true vacuum state could exist. The horror is that a single, random quantum event anywhere in the cosmos could create a tiny bubble of this true vacuum. This is vacuum decay. Once formed, this bubble would not simply sit there. It would expand in all directions at the speed of light, a wall of fundamental change remaking the universe as it goes. The bubble itself would not be an explosion of force. You would not see a wall of fire coming. It would be a rewriting of the rules. As this boundary swept through a region of space, it would permanently alter the laws of physics within it. The fundamental constants that govern how particles interact, that allow atoms to form and stars to shine, would be reset. The forces that hold your very atoms together could simply cease to exist in their current form. Inside this new reality, matter as we know it would become impossible. Every planet, every star, every living thing would instantly and silently cease to be. It would not be a destruction of matter, but an unmaking of its very nature. One moment, a galaxy teeming with billions of stars exists. The next moment, it is gone, not into rubble, but into a new state of existence where the concepts of stars and life have no meaning. The process is as final as it is swift because the bubble expands at light speed. There is no warning. You cannot see it coming. One instant you are living your life. The next, an invisible wall of altered physics has already passed over you, and everything you ever knew has been erased from the universe. This is not a threat from a distant supernova or a wandering black hole. It is a flaw in the very fabric of existence, a ticking time bomb set at the dawn of time that could go off right now, a million light years away, and we would never know what ended us. The cosmos would simply change, leaving no one to mourn what was lost. A silent and irresistible river of galaxies flows through the cosmos, and our Milky Way is caught in its current. This is the mystery of the Great Attractor, a gravitational anomaly of such immense power that it is pulling our entire galaxy, along with countless others, toward an unseen point in the void. We are racing toward this enigmatic destination at over 1,000,000 miles per hour, yet we cannot see what awaits us. The heart of this cosmic puzzle lies hidden behind the thick dust and brilliant stars of our own galaxy's central plane, a region astronomers call the zone of avoidance. It is like trying to see a distant city from the middle of a dense, foggy forest. Our own galactic home blocks the very view we desperately need. For decades, this obscurity fueled wild speculation. Was it a single, impossibly massive object, a gravitational monster of unseen proportions? Further observations have revealed part of the answer. The pull is largely due to an enormous concentration of mass known as the Laniakea supercluster, a web of hundreds of thousands of galaxies of which we are but a small part. Yet, even this vast structure may not fully account for the strength of the pull, leaving room for the possibility of something even more exotic and unknown lurking in the darkness. This cosmic siren call tugs at the very fabric of our local universe, drawing us toward a fate we can only guess at. While a collision of galaxies is not the immediate threat, the sheer force of this unseen hand guiding our long-term trajectory through the cosmos is a humbling reminder that we are not merely observers of the universe, but passengers on a journey whose ultimate destination remains shrouded in mystery. This immense directional pull is unsettling enough, but what if the very substance of the cosmos was actively working against us? Even the dead do not rest easy in the cosmos. A star that has burned through its fuel and collapsed into a white dwarf, a dense Earth-sized ember of carbon and oxygen, can be reawakened with a violent fury. These are the zombie stars, stellar corpses that feed off the living. The process begins in a binary system where the white dwarf has a companion star, often a bloated red giant. The dwarf's immense gravity acts as a celestial siphon, relentlessly pulling hydrogen-rich gas from its partner. This stolen matter spirals down onto the white dwarf's surface, accumulating over millennia. For a time, it may seem stable, a quiet theft in the void, but this stolen life has a price. The white dwarf is walking a tightrope, edging toward a catastrophic rebirth. It has a strict limit, a mass of about 1.4 times that of our Sun, known as the Chandrasekhar limit. As it steals more and more matter, it inches closer to this threshold. The increasing pressure and heat at its core become unbearable. In a single, shattering instant, the entire star reignites in a runaway thermonuclear explosion. This is a Type Ia supernova, a detonation so brilliant it can, for a few weeks, outshine every other star in its host galaxy combined. It is the final, spectacular death of a star that was already dead, a resurrection that annihilates it completely, leaving behind no remnant but an expanding cloud of glowing elements. We rely on the predictable brightness of these explosions as cosmic mile markers, standard candles to measure the vast expanses of the universe, yet this very usefulness underscores their terrifying power. They remind us that a quiet, fading ember in a distant star system can, at any moment, be transformed into the brightest beacon of destruction imaginable, a final act of consumption that echoes across the light years. The silent exile of a star is a terrifying spectacle. While our own sun travels a steady path around the galactic center, some stars are not so fortunate. They are the hypervelocity stars, celestial projectiles flung from their home galaxies at speeds exceeding 1,000,000 miles per hour. Their origin story is one of pure gravitational violence. Most are born in binary pairs, two stars orbiting one another that drift too close to the supermassive black hole at the heart of their galaxy. The black hole's immense gravity captures one star, pulling it into a tight, doomed orbit. In a cosmic slingshot maneuver, its companion is hurled away at an astonishing velocity, ejected from the galaxy entirely, never to return. These stars become permanent loners, condemned to race through the unimaginable emptiness between galaxies, their light a solitary beacon in an ocean of nothingness. The journey of a hypervelocity star is one of profound isolation. For billions of years, it will travel through the intergalactic void, a place so empty that the nearest star is not just a few light years away, but millions. Its brilliant blue-white light, a testament to its youth and speed, would illuminate nothing but the endless dark. It is a ghost ship sailing an infinite, starless sea. The danger, however, lies in the remote but real possibility of such a star passing through our own solar system. It would not need to strike a planet to cause chaos. Its gravitational influence alone would be enough to wreak havoc. As it plowed through the outer reaches of our system, it would disrupt the delicate gravitational balance of the Oort cloud, that vast shell of icy bodies surrounding our sun. This stellar intruder would act like a cue ball scattering a rack of billiard balls, sending countless comets on new, inward-bound trajectories. A rain of icy missiles would begin a long fall toward the inner solar system, a celestial storm that could last for millions of years, bombarding planets and threatening any life that exists. While the odds are incredibly low, the image of a brilliant, runaway star tearing through the peaceful darkness of our cosmic neighborhood, leaving a trail of orbital chaos in its wake, is a chilling reminder that the galaxy can be a violent and unpredictable place. The silent, swift journey of a hypervelocity star is a voyage through a crowded metropolis compared to the true emptiness that awaits. Deep within the constellation of Boötes lies a cosmic desert so vast it defies belief. This is the Boötes Void, a spherical region of space roughly 330 million light-years across that contains almost nothing. If you were to place our Milky Way galaxy at its center, you would find yourself in near total isolation, with perhaps only a handful of other galaxies visible in a volume of space that should hold thousands. This great nothingness is not a blank spot on our maps. It is a staggering anomaly in the fabric of the cosmos, a hole in the universe itself. Its existence challenges our most fundamental ideas about how the universe formed. We expect matter to be distributed in a vast cosmic web, with great clusters and filaments of galaxies separated by relatively empty bubbles. But the Boötes Void is not a bubble, it is a chasm. How could such an immense region end up with so little inside? One theory suggests it is the result of many smaller voids merging over billions of years, like soap bubbles coalescing into one giant one. Yet its sheer scale pushes this idea to its limits, leaving some to wonder if a more exotic, unknown process carved out this emptiness in the early universe. Imagine a civilization born on a world within the void. Their night sky would be a profound and permanent black. With no nearby galaxies, the concept of a universe filled with billions of stellar islands would be pure mythology. They would gaze up and see only a handful of faint, fuzzy smudges, their own local group, against an abyss of nothing. They would believe their tiny cluster was the entire universe, completely unaware of the vibrant cosmic web just beyond their dark horizon. Their profound isolation would be both a scientific prison and a source of existential dread, a loneliness on a scale we can barely fathom. The Boötes Void stands as a silent monument to the fact that the cosmos can create not just terrifying forces, but also terrifying absences. Our own star, the Sun, holds a quiet rage that could undo our modern world in a single day. We think of it as a steady, life-giving force, but it is a dynamic and sometimes violent ball of plasma. Solar flares are common, intense bursts of radiation from the sun's surface, but astronomers have observed other sun-like stars unleashing superflares, eruptions 10,000 times more powerful than anything we have ever recorded. Our sun is perfectly capable of producing one of these cataclysmic events. The destruction would not come from heat or fire, but from an invisible and overwhelming wave of magnetized plasma. When a superflare erupts, it hurls a colossal cloud of charged particles, a coronal mass ejection, directly into space. If Earth were in its path, this solar storm would strike our planet's magnetic field like a cosmic tsunami. The resulting geomagnetic storm would be unlike anything our civilization has ever experienced. The real terror begins deep underground, with the vast networks of electrical wires that power our world. The fluctuating magnetic field would induce enormous, uncontrollable electrical currents in these long conductors. Power transformers, the massive and difficult-to-replace hearts of our electrical grids, would overload and melt into useless hunks of metal. The entire grid would fail, not for days, but potentially for years. One moment, the world is illuminated and connected. The next, it is plunged into a silence and darkness we have not known for over a century. Every satellite in orbit would be fried by the radiation, ending global positioning, communications, and weather monitoring. Banking systems, the internet, and water treatment plants would cease to function. We have a chilling precedent, a warning from a less connected age. In 1859, the Carrington event, a solar storm far weaker than a superflare, caused telegraph systems across Europe and North America to fail, with operators receiving shocks and papers catching fire from the electrical surges. A similar event today would cause trillions of dollars in damage and cripple our technological society. The evidence from other stars tells us it is not a matter of if, but when. Scientists now monitor the sun constantly, watching for the signs of an immense buildup of magnetic energy that could foretell such an eruption. Yet, even with warning, our ability to shield the planet's entire electrical infrastructure is limited. We are living in the calm before a potential storm that our own star could unleash at any time, a reminder that our greatest source of life could also be the agent of our technological collapse. The sun's potential for technological devastation is a threat we can see and measure, but a far greater and more mysterious substance holds our entire galaxy in its clutches. We are not just traveling through space, we are swimming in an invisible ocean, a ghostly presence that permeates every corner of the cosmos. This is dark matter, the universe's greatest unsolved mystery. It makes up about 85% of all the matter in existence, yet it emits no light, reflects no light, and interacts with normal matter only through the faintest whisper of gravity. We know it is there because without its immense, unseen mass, our galaxy would simply fly apart. The stars at the outer edges of spiral galaxies rotate so quickly that the visible matter alone could never hold them in their orbits. It is as if you saw a child's pinwheel spinning, but the plastic blades were moving faster than the central hub could possibly allow, suggesting an invisible, heavier structure was doing the real work. The evidence is everywhere. We see its signature in the way massive clusters of galaxies bend the light from more distant objects behind them, a phenomenon called gravitational lensing. The light from these faraway galaxies curves around something we cannot see, tracing the outline of dark matter's hidden architecture like a cosmic shadow puppet. We are surrounded by this phantom mass, a substance that flows through you and everything you know right now, yet we have absolutely no idea what it is. The most unsettling part is not its invisibility, but our profound ignorance. We have given a name to our own lack of understanding. This has led to speculative and deeply strange ideas. Could dark matter form its own structures? What if there are dark matter stars, colossal spheres of this ghostly material, burning with some unknown, invisible fuel? Or dark matter planets, entire worlds made of a substance that normal matter would simply pass through. A spaceship could fly directly through the heart of such a world and never know it was there. Even more bizarre is the possibility of complex, invisible structures right here in our own solar system, a hidden geography woven between the atoms of our reality. We are living in a universe dominated by a ghost, a silent partner whose true nature remains one of the most profound and humbling terrors of the cosmos. And if an invisible substance governing everything is not unsettling enough, consider that the universe itself might be actively trying to tear itself to pieces. Dark matter's invisible architecture binds our galaxy, yet the silence from beyond is even more deafening. The universe is unimaginably vast and ancient, with billions of planets that could harbor life. So where is everybody? This is the Fermi Paradox, a question that transforms the starry sky from a thing of beauty into a canvas of profound and terrifying mystery. The sheer number of potential civilizations should mean the cosmos is buzzing with activity, filled with the radio chatter and engineering projects of countless species. Yet we hear nothing but an endless, empty static. The solutions to this paradox are in many ways more frightening than the silence itself. One of the most chilling ideas is the Great Filter. This theory suggests that the evolution of life from its genesis to a spacefaring civilization is not a smooth path, but an obstacle course with one nearly impossible step. Somewhere along that path, from the formation of planets to the development of intelligence and technology, a wall appears that almost no species can climb over. The terrifying part is we do not know if this filter is behind us or still ahead. If it is behind us, we are a statistical miracle, one of the very few to have made it this far. But if it lies ahead, it means our own destruction is woven into the fabric of our future progress. This filter could be an inevitable technological development, like self-replicating nanomachines that consume the biosphere, or artificial intelligence that decides its creators are obsolete. It could be a natural cycle of cosmic extinction we have not yet encountered, like the gamma-ray bursts we have already discussed. The silence of the universe may be the evidence that every other civilization that reached our level of advancement has already been wiped out by a fate we cannot yet see coming. Another possibility is even more predatory. Perhaps the universe is not empty but full of hunters. In this dark forest scenario, every civilization is like a hunter moving through a dark wood, knowing that any sound could attract a predator. To broadcast your presence is to invite annihilation from a more advanced species that sees you as a threat, a resource, or simply competition. The silence we observe is not a sign of emptiness, but of a universe where everyone is hiding, listening intently for a foolish signal before they strike. Our own attempts to communicate, like the messages we have beamed into space, could be the equivalent of shouting in that dark forest, unaware of what might be listening. Or perhaps the truth is the most lonely of all. We could simply be the first. In the grand timeline of the universe, intelligent life may be an extraordinarily rare and recent phenomenon. We might be the pioneers, gazing out at a silent, unpopulated cosmos, waiting for others to emerge and join us in the great conversation. This places a profound and heavy responsibility on our shoulders, for we would set the precedent for all who might follow. Each of these answers carries its own unique form of existential dread. Are we the lone survivors of a cosmic catastrophe? Are we the prey in a galactic jungle? Or are we the lonely children of a universe still waiting to wake up? The empty starfields we find so beautiful are a constant, silent reminder of this unsettling question. Our own world is a fragile oasis, and the silence of the cosmos may be a warning we are only beginning to understand. Just next door, a terrifying example of planetary catastrophe has already played out. Venus is Earth's twisted sister, a world of almost identical size and composition that underwent a horrifying transformation. Its surface is a true vision of hell, with temperatures soaring to nearly 900 degrees Fahrenheit, hot enough to liquefy lead. Thick clouds of sulfuric acid shroud the planet, and the atmospheric pressure is 90 times greater than Earth's, equivalent to the crushing weight found a kilometer deep in our oceans. This is the ultimate result of a runaway greenhouse effect, a process where a planet's atmosphere traps so much heat that it triggers a chain reaction of utter devastation. Scientists believe Venus may have once been a very different world, possibly even possessing shallow oceans like early Earth. But as the sun grew brighter over billions of years, the increased warmth began to evaporate more water vapor into Venus's atmosphere. Water vapor is itself a potent greenhouse gas, trapping heat and causing further warming, which in turn evaporated even more water. This positive feedback loop spiraled out of control. The planet's oceans may have boiled away entirely, and the water molecules, broken apart by solar radiation, allowed hydrogen to escape into space while the oxygen bonded with rocks. With no oceans left to absorb carbon dioxide, the gas built up in the atmosphere, creating an impenetrable thermal blanket that sealed the planet's fate. The terrifying part is that the same fundamental physics apply here on Earth. Our climate is stabilized by a delicate balance, but we are adding immense amounts of carbon dioxide to our own atmosphere, pushing the system toward an uncertain tipping point. Imagine a world where our polar ice caps, which reflect a tremendous amount of solar energy back into space, have completely vanished. The newly exposed dark ocean water absorbs that heat instead, accelerating global warming. Warmer oceans cannot hold as much dissolved carbon dioxide, so they begin releasing vast stores of the gas back into the air, further intensifying the greenhouse effect. Vast deposits of methane, another powerful greenhouse gas frozen in permafrost, could be unlocked, adding more fuel to the fire. These are the same kinds of feedback loops that turned Venus into a furnace. While Earth is unlikely to become as extreme as Venus due to our greater distance from the Sun, the principle remains a chilling cautionary tale. The difference between a habitable world and a scorching wasteland is a surprisingly thin atmospheric line. We are conducting an unprecedented planetary experiment, and Venus stands as a permanent, brooding monument to what can happen when a climate is pushed over the edge. The ghostly architecture of dark matter binds our galaxy, but at its very heart, a different kind of monster can awaken. Deep in the core of some distant galaxies, a beacon of pure fury shines with the light of 1 trillion suns. These are quasars, the most luminous objects in the entire universe. A single quasar can outshine every single star in its home galaxy combined, its brilliance visible from billions of light years away. This unimaginable power does not come from stars, but from a supermassive black hole in a state of ravenous, gluttonous feasting. As colossal amounts of gas, dust, and even entire stars spiral into the black hole's accretion disk, the material is heated to millions of degrees, blazing with light across the electromagnetic spectrum before vanishing forever across the event horizon. This is a cosmic engine of breathtaking efficiency, converting matter into pure energy on an industrial scale. But the true terror of a quasar is not just its blinding core. From the poles of this spinning maelstrom, it can fire out twin jets of superheated plasma and radiation, stretching across space for hundreds of thousands of light years. These jets are particle accelerators on a galactic scale, channeling the black hole's leftover energy into focused beams that travel at nearly the speed of light. If a world like Earth were to find itself in the crosshairs of one of these relativistic jets, the consequences would be instantaneous and absolute. A blast of high-energy gamma rays, X-rays, and cosmic particles would strike the planet's atmosphere, tearing it apart molecule by molecule. The surface would be scoured by radiation, sterilizing the entire world in a flash. The oceans would boil, the rock would glow, and every trace of life would be erased in a geological instant. Fortunately for us, the nearest known quasars are fantastically distant, their brilliant beams aimed harmlessly away from our quiet corner of the cosmos. Yet their existence is a stark reminder of the violence that slumbers in the heart of most galaxies, including our own. The same supermassive black hole that quietly anchors the Milky Way, Sagittarius a star, was likely a brilliant quasar in the distant past and could theoretically be reawakened by a fresh influx of matter. These cosmic lighthouses do not just illuminate the distant universe, they illuminate a terrifying potential that lies dormant in the galactic core, a sleeping dragon whose breath could end worlds. While the silent threat of a distant quasar is immense, a far more immediate danger is taking shape right above our heads. The space around Earth is no longer a pristine void. It has become a crowded junkyard filled with thousands of active satellites and millions of pieces of discarded debris, all traveling at orbital velocities of over 17,000 miles per hour. At these speeds, even a fleck of paint carries the kinetic energy of a bullet. This sets the stage for a terrifying chain reaction known as the Kessler syndrome. Imagine a single collision between a defunct satellite and an old rocket body. The impact would not be a simple crash. It would be a hypervelocity explosion, shattering both objects into a vast, expanding cloud of shrapnel. Each new piece, from a bolt to a jagged metal slab, becomes a new projectile. This cloud then spreads through orbit, dramatically increasing the probability of another collision. That second impact creates even more debris, which leads to a third and a fourth. The process becomes a runaway cascade, a domino effect of destruction. Within a matter of years or even months, low Earth orbit could become a maelstrom of high-speed shrapnel, an impenetrable shell of debris encircling our planet. The consequences of such an event would be immediate and devastating for our modern world. The first casualties would be our vital satellites. The International Space Station would be evacuated, its hull vulnerable to punctures. Our global positioning systems, which guide everything from navigation to financial transactions, would go dark. Weather satellites, our eyes on approaching storms, would be blinded. Communication networks that rely on orbital relays would fail. We would lose our strategic view of Earth, our ability to forecast disasters, and our global connectivity in a single cascading failure. But the ultimate terror is the long-term imprisonment. This shrapnel field would not simply fade away. In the thin atmosphere of low Earth orbit, there is very little drag to pull debris down. A cloud created by a single major collision could remain in orbit for centuries, maybe even a millennium. Every rocket we tried to launch would have to fly through this orbital minefield with a high probability of being destroyed. Humanity will be trapped on Earth, our access to the final frontier severed just as we were taking our first steps. The dreams of moon bases, Mars colonies, and deeper space exploration would vanish, replaced by the silent, glittering barrier of our own discarded technology. This is not science fiction. The concern is so real that space agencies around the world constantly track over 30,000 objects larger than a softball. We have already witnessed warning shots. In 2009, a defunct Russian satellite collided with an active American commercial satellite, instantly creating thousands of new pieces of trackable debris. Every time a country tests an anti-satellite missile by blowing up one of its own satellites, it deliberately adds thousands of fragments to this growing orbital hazard. The effort to prevent a Kessler cascade is a race against time. Engineers are developing cleanup technologies, concepts like harpoons, nets, and magnetic tethers to capture and orbit large pieces of junk. But the scale of the problem is immense, and the political and financial challenges of a global cleanup operation are staggering. We are in a precarious balance, adding new satellites to orbit at an unprecedented rate while the ghostly shrapnel from our past mistakes continues to silently cross our path. The greatest threat to our future in space may not come from the void, but from the shell of our own ingenuity now threatening to entomb us. The silent, automated cascade of orbital debris is a danger of our own making, but the cosmos has its own natural cataclysms that dwarf our local troubles. When two of the universe's most bizarre and dense objects decide to dance, the result is a spectacle of pure, unadulterated violence. These are neutron star mergers, the collisions of stellar corpses so dense that a single teaspoon of their material would weigh billions of tons on Earth. Born from the supernova explosions of massive stars, these city-sized remnants are the atomic nuclei left behind, packed so tightly that their very protons and electrons have been crushed together into neutrons. They are essentially gigantic atomic nuclei spinning frenetically through space. When two of them become locked in a gravitational embrace, their fate is sealed. They begin to spiral inward, losing orbital energy by rippling the very fabric of space-time, creating gravitational waves that we can now detect across billions of light years. The final moments of this dance are both beautiful and terrifying. As they draw closer, their immense gravity begins to tear them apart, stretching each star into a teardrop shape. They make one final, furious orbit around each other, hundreds of times per second, and then they collide. The impact is not a gentle merging. It is a titanic smash, a cosmic car crash of unimaginable force. In that single, shattering instant, the universe forges the elements of life and wealth. For eons, astronomers wondered where the heaviest elements like gold, platinum, and uranium came from. Regular stars and supernova could not account for their abundance. The answer was found in the heart of this incredible collision. The extreme conditions, flooded with a dense shower of neutrons, allow for a rapid capture process, forcing atomic nuclei to grow in an instant into the heaviest elements known. The gold in your wedding ring, the platinum in a catalytic converter, every precious, heavy atom was likely born in a cataclysmic event like this, forged in a blast that occurred billions of years ago, long before our solar system even existed. This creative burst, however, is also a beacon of destruction. The merger unleashes a kilonova, an explosion that can briefly outshine a star, and it often produces a short gamma-ray burst, one of the most energetic events in the universe. If a habitable world were located within a few thousand light-years of such an event, the consequences would be apocalyptic. The planet would be bathed in a torrent of high-energy radiation and cosmic rays, effectively sterilizing its surface and stripping away its atmosphere. The very event that seeds the galaxy with the building blocks for planets and life is also a galactic-scale sterilizer, a paradox of cosmic creation. We are here because such events happened in our galactic neighborhood long ago, enriching the cloud of gas and dust that would become our sun and planets. Yet the knowledge that these beautiful, element-forging explosions are also engines of utter annihilation adds a profound and terrifying duality to our cosmic origins. The creative fire of a neutron star merger is a fleeting spark against the ultimate, chilling truth of our cosmos. Every story, every star, every civilization will one day face the same final page. The universe is not just expanding, it is running down. This is the principle of entropy, a measure of disorder that always increases. Think of it like a hot cup of coffee left in a cold room. The heat naturally flows from the coffee into the air until both are the same lukewarm temperature. No more energy can be extracted from that system. Nothing else can happen. Now apply that to the entire cosmos. All the energy stored in stars, in galaxies, in the very matter that makes us up, is slowly but irrevocably spreading out. The universe is that cup of coffee cooling in an infinite room. Billions of years from now, the last stars will exhaust their fuel. The brilliant blue giants will be long gone. The smaller, frugal red dwarfs will finally sputter out, their faint red light fading to black. One by one, the lights will go out across the cosmos, leaving galaxies as dark, silent graveyards of dead stars. For a time, the universe will be a realm of black holes, but even these titans are not eternal. Through a bizarre quantum process at their event horizons, they slowly leak radiation, evaporating over incomprehensible spans of time. The largest black holes will take trillions upon trillions of years, but they too will eventually vanish in a final, faint puff of particles. This is the era of darkness. All that remains is a thin, ever-expanding sea of subatomic particles and radiation, spread so thinly that any two particles may be separated by cosmic voids larger than our observable universe today. The temperature everywhere will approach absolute zero, the point where all molecular motion stops. In this state of maximum entropy, no energy gradients remain. There can be no hot or cold regions, no clumps of matter, no stars to form, no planets to orbit. The universe will be uniform, a perfect and featureless void. This is the heat death, the ultimate equilibrium. It is not an end of violence or cataclysm, but an end of possibility. No thought can form, no memory can be stored, no action can be taken. Time itself may become meaningless as there are no events to mark its passage. The cosmos will be frozen in a silent, dark, and eternal stillness, a final chapter from which no new story can ever be written. The final, silent chill of the heat death is a fate written in the distant future, but a more immediate and rhythmic danger pulses in the darkness today. A pulsar is the universe's ultimate warning beacon, a spinning corpse that refuses to fade away quietly. When a massive star goes supernova, its core can collapse into a city-sized sphere of neutrons, a substance so incredibly dense that a single sugar cube's worth would weigh more than every single person on Earth combined. This stellar remnant begins to spin at a dizzying rate, sometimes hundreds of times per second, and its intense magnetic fields focus twin beams of radiation from its poles. Like a cosmic lighthouse, these beams sweep through space, and if one of those beams happens to point toward Earth with each rotation, we detect a regular, repeating pulse of radio waves, X-rays, or gamma rays. The precision of these pulses is staggering, rivaling the accuracy of atomic clocks. Yet this mesmerizing rhythm is the heartbeat of a celestial predator. The energy in those sweeping beams is unimaginably intense, a concentrated torrent of radiation that would instantly fry the electronics of any spacecraft and prove lethal to any life on a planet unfortunate enough to be caught in its path. It is a rotating death ray, methodically scouring its surroundings with every spin. Some pulsars take this predatory nature to an even more sinister extreme. Astronomers have discovered systems known as Black Widow pulsars, named for the spider that consumes its mate. In these binary dances, the pulsar's powerful winds and radiation relentlessly blast its companion star, slowly but surely evaporating it. The pulsar siphons off material from its partner, a process that actually speeds up its own spin, all while systematically stripping the other star down to its core. It is a gruesome, long-term act of stellar cannibalism, where one dead star uses the life force of another to rejuvenate itself, leaving behind only the ghost of what was once a sun. These cosmic lighthouses do not guide travelers to safety. They mark the graves of stars and the potential end of worlds. Their regular, metronomic pulse a chilling reminder of the violent physics that govern the graves of stars. The slow, cold fade of heat death offers a quiet end, but the cosmos may have a far more violent finale in store. The universe's expansion is not just continuing, it is accelerating, driven by a mysterious force we call dark energy. This force acts as a kind of anti-gravity, pushing space itself apart. Now, imagine a future where this push does not just continue, but grows infinitely stronger. This is the terrifying premise of the Big Rip. If the repulsive power of dark energy increases over time, it will eventually overcome every force that holds the universe together. The first structures to go will be the largest. The gravitational glue binding entire galaxy clusters will be no match for the overwhelming push of dark energy. These vast cities of stars will be flung apart into the void, their connections severed forever. Next, the galaxies themselves will be torn asunder. The delicate gravitational dance that keeps billions of stars in a swirling disk will be broken. Every star will be sent flying on its own solitary trajectory, a lonely ember in an ever-widening emptiness. The destruction will then move inward to our very own solar system. The Sun's gravity, which has held the planets in a stable orbit for billions of years, will suddenly count for nothing. Earth will be ripped away from its life-giving star, hurled into the freezing, lightless depths of interstellar space. But the horror does not stop at the planetary scale. As the fabric of space-time continues to tear itself apart, the force will reach down to a planetary level. The very gravity that holds a planet together, that gives it its spherical shape, will be overpowered. Worlds will literally be shredded, exploding into clouds of rock and dust. Then it reaches the atomic scale. In the final, unimaginable moments, the force will exceed the nuclear strong force, the fundamental power that binds the protons and neutrons together in an atom's nucleus. In a single, catastrophic instant, every atom in the universe will be torn apart. Every molecule, every piece of matter will be reduced to a diffuse, disconnected fog of elementary particles, unable to ever interact or form anything ever again. Where the heat death is a slow, cold whisper into silence, the big rip is a cosmic scream. It is not a fading of the lights, but the violent demolition of the entire theater of existence, from the grandest galaxy down to the very building blocks of reality. The universe would not just grow dark and cold, it would be utterly and irreversibly disassembled. Even as you sit perfectly still, you are being bombarded by a silent, invisible rain from deep space. These are cosmic rays, subatomic bullets composed mostly of protons, accelerated to nearly the speed of light by the most violent events in the universe. They are the shrapnel from supernova explosions, the exhaust from feasting black holes, and they constantly streak through the void, piercing everything in their path. Our planet's atmosphere and magnetic field serve as a vital shield, absorbing most of this radiation and turning it into the harmless, shimmering glow of the aurora. But above this protective blanket, the danger is very real. For astronauts on the International Space Station or on a journey to Mars, this particle rain is a persistent, health-threatening hazard. Imagine a tiny, high-energy proton screaming through an astronaut's body. It does not just pass through harmlessly. It can smash directly into the delicate strands of DNA within a cell's nucleus, breaking the genetic code and increasing the long-term risk of cancer. Astronauts report seeing flashes of light behind their eyelids, a phenomenon caused by these high-energy particles directly striking their retinas. The spacecraft itself offers only partial protection, its hull sometimes creating a secondary shower of even more particles when a cosmic ray slams into it. This radiation is an unavoidable peril of venturing beyond our planetary cradle. The threat extends to our robotic companions as well. Satellites in orbit are also vulnerable. A single, well-aimed cosmic ray can strike a critical computer chip, flipping a single 1 to a 0 or a 0 to a 1. This single event upset can cause a satellite to malfunction, lose its orientation, or even suffer a permanent systems failure. Visualize the interior of a multi-million-dollar communications satellite, where a silent, invisible particle impact causes a sudden spark and a cascade of erroneous commands, turning a vital piece of technology into silent, drifting junk. Yet all of these particles are mere specks of dust compared to the true cosmic artillery. In 1991, a cosmic ray detector in Utah recorded something that defied all understanding. It was a single subatomic particle, most likely a proton, but it carried an energy that was utterly staggering. Dubbed the "Oh my God" particle, it was traveling at such an incredible speed that it possessed the kinetic energy of a baseball pitched at 60 miles per hour, all compressed into a single, fundamental piece of matter. The energy of this one tiny particle was millions of times greater than anything our most powerful particle accelerators, like the Large Hadron Collider, can ever produce. The existence of such a projectile shatters our understanding of physics. What cosmic event could possibly be so powerful, so unimaginably violent, that it can launch a single proton with the force of a major league fastball? It did not come from a mere supernova. That would be like using a nuclear bomb to propel a grain of sand. The source must be something far more extreme, perhaps a supermassive black hole at the heart of an active galaxy, or the cataclysmic collision of entire galaxy clusters. The oh my god particle is a mystery and a warning, a hint that the universe holds accelerators of such ferocious power that they can forge bullets capable of traveling across billions of light years, each one a silent testament to forces that dwarf our greatest imaginations. That single, impossibly energetic particle was a message of pure violence, but another signal from the void carried a different, more haunting kind of terror. On a quiet Ohio night in August 1977, the Big Ear radio telescope was performing its monotonous sky survey, listening to the faint hiss of the cosmos. The data printed out line by line on simple computer paper, a string of letters and numbers representing signal intensity. For the most part, it was a river of empty noise. Then, for exactly 72 seconds, the telescope's fixed gaze swept over a patch of sky in the constellation Sagittarius, and the printer went wild. The sequence read 6EQUJ5. This was not a random spike. It was a strong, narrowband radio signal, the exact type of signature we would expect from an artificial interstellar beacon. It was over 1 million times louder than the background noise of space, and it came and went as the Earth's rotation swept the telescope's field of view across that single point, exactly as a signal from a distant fixed source would. The astronomer reviewing the data, Jerry Amon, was so stunned by the perfect characteristics of the signal that he circled the alphanumeric sequence on the printout and wrote a single, emphatic word in the red pen margin. Wow, this one word named a mystery that has endured for decades. The wow signal was everything scientists had hoped to find, a radio scream in the silent wilderness that ticked every box for a potential alien transmission. The terrifying part is that we heard it only once, despite decades of follow-up observations. Listening to that same patch of sky with far more sensitive equipment, the signal has never been heard again. It was a one-time event, a brief, brilliant flash in the cosmic dark. This fleeting nature makes a natural explanation frustratingly elusive. It could not have been a passing satellite or aircraft, as those move and would have created a different signature. It was not a random burst from a known celestial object. The most compelling natural theories, like a comet emitting hydrogen, have been proposed and subsequently debunked, failing to match the specific location or signal properties. The wow signal remains an enigma, a perfect candidate for an artificial origin with no satisfactory natural answer. The implications are profound and deeply unsettling. What if we briefly intercepted a message not meant for us? A fragment of a civilization's internal communications, perhaps, or a lighthouse beacon sweeping the galaxy, whose beam washed over Earth for just over a minute before moving on. It is the ultimate cosmic missed call, a hello from the darkness that we heard but could not understand and could not answer. Our own radio signals have been leaking into space for over a century, a growing bubble of noise announcing our presence. The wow signal forces us to wonder if we finally received a reply, a single, enigmatic word in a language we cannot decipher, a whisper that raises the terrifying possibility that we are not alone, but that conversation may be impossibly brief and eternally lonely. The silent, one-time whisper of the wow signal hints at a cosmos that might be listening, but a far more tangible and ancient predator could be drifting right past our cosmic doorstep. The supermassive black holes that anchor galaxies can sometimes be violently evicted from their thrones. During the chaotic mergers of entire galaxies, the central black holes can spiral together, and in their final dance, the recoil from the emission of powerful gravitational waves can kick the newly merged monster clear out of its galactic home. These are rogue black holes cast out to wander the unimaginable emptiness between galaxies. They are the ultimate invisible hunters, their presence betrayed only by the most subtle of clues. As one of these dark masses drifts through space, its immense gravity warps the fabric of spacetime around it, acting like a cosmic magnifying glass. The light from distant stars behind it will bend and distort, a phenomenon known as gravitational lensing. A star field would momentarily shimmer and twist, its patterns stretched into faint, ethereal arcs around a central point of absolute nothingness. This gravitational mirage is the only warning we might ever get. The true nightmare begins if such a wanderer charted a course through our own solar system. It would not need to be a supermassive giant to cause absolute chaos. Even a stellar mass rogue a few times heavier than our Sun would be a gravitational wrecking ball. Long before we could see it, its pull would begin to tug on the outer planets, subtly altering their orbits. The delicate clockwork of our solar system would be thrown into disarray. The Oort cloud, that vast reservoir of icy bodies at the solar system's edge, would be stirred into a frenzy, sending a storm of comets hurtling inward. As the black hole drew closer, its influence would grow stronger, warping the paths of the gas giants and eventually the inner rocky planets. Earth could be flung out into the frozen depths of interstellar space or thrown into a death spiral toward the Sun. And if any object, a planet, an asteroid, or a spacecraft ventured too close, it would be captured. We would witness the final, terrifying spectacle of matter being torn apart, superheated into a brilliant, swirling disk of incandescent plasma around an utterly dark central point, a final scream of light before being silenced forever across the event horizon. The most chilling part is the silence of its approach. With no accretion disk to glow, no companion star to illuminate it, a lone rogue black hole could be upon us with almost no warning, a ghost in the celestial machinery whose first sign might be the stars themselves beginning to waver in the night sky. A single sheet of paper in 1961 framed the entire search for alien life. Astronomer Frank Drake wrote down a simple formula, a chain of probabilities that would become the most famous equation in the search for cosmic company. The Drake equation is not a tool for a single answer, but a framework for a profound debate. It asks how many civilizations in our Milky Way are out there, right now, broadcasting signals we could potentially hear. The equation begins with the grand and the certain, the raw materials of life. It starts with the rate of star formation in our galaxy. We see new suns being born all the time. Then it asks what fraction of those stars have planets. For decades, this was a guess, but now we know planets are common. Almost every star has at least one. Next, it considers how many of those planets are habitable, orbiting in that just right Goldilocks zone where liquid water could exist on the surface. The galaxy begins to feel crowded with potential. Then, the equation takes its first leap into the unknown. Of all those suitable worlds, on what fraction does life actually appear? Is the spark of life a cosmic inevitability given the right conditions, or a stunningly rare fluke? If life does begin, what fraction of that life evolves into intelligent, tool-using beings? The universe is ancient, and dinosaurs ruled Earth for over 150 million years without ever developing radio telescopes. Intelligence is not a guaranteed destination of evolution. The final factors are the most chilling because they speak to our own future. Of those intelligent civilizations, what fraction developed the technology and the desire to communicate across the stars? And finally, the most haunting variable of all, how long do such civilizations last? What is the average lifetime of a species that can announce its presence to the cosmos? This is where the equation transforms from a scientific curiosity into a source of existential dread. Let us plug in optimistic numbers. Imagine life is common, intelligence arises frequently, and civilizations are long-lived. The galaxy should be a vibrant metropolis humming with countless conversations. The sky should be full of voices, yet we hear only silence. This is the burden of the Fermi Paradox, and it suggests a terrible possibility. That final variable, the lifetime of a civilization, must be tragically short. Something must be stopping them, a great filter that destroys civilizations shortly after they become technological. The filter could be an innate self-destructive tendency, war or environmental collapse, or an external threat like the gamma-ray bursts we have already discussed. The terrifying implication is that this filter likely still lies in our own future. Now, let us use pessimistic numbers. Imagine life is a 1 in a trillion accident, and intelligence is even rarer. The final answer to the Drake equation could be 1, just us. We would be the only thinking beings in this vast, swirling collection of 400 billion stars, the sole witnesses to the galaxy's majestic, silent evolution. The entire cosmic story, from the first stars to the last, would play out with no one else to comprehend its beauty or its terror. Our art, our music, our love, and our loss would be a solitary, fleeting phenomenon in an indifferent void. Both outcomes are equally terrifying. A crowded galaxy means we are likely doomed to an early death, our bright signal soon to be snuffed out. An empty galaxy means we are doomed to an eternal, profound loneliness. The Drake equation holds up a mirror, and the reflection we see is our own precarious place in the cosmos, balanced between the fear of a universe that is too loud and the horror of one that is forever silent. Beyond the last planet's orbit, beyond even the faint, frozen realm of Pluto, our solar system does not simply end. It is enveloped by a ghostly, spherical shell of ancient ice, a vast reservoir of primordial building blocks left over from the solar system's birth. This is the Oort cloud, a region so distant and diffuse it is more a concept than a place, stretching nearly halfway to the next star. Trillions of icy bodies, some as large as mountains, drift here in a deep freeze that has lasted for billions of years. They are the silent, untouched archives of the early solar system, but their peace is fragile. The sun's gravitational hold on these distant objects is incredibly weak, a tenuous tether in the void. A chance event is all it takes to turn an archival relic into a missile. The gentle gravitational nudge of a passing star, an event that happens every few 100,000 years, can be enough. Even the cumulative tidal pull of the entire Milky Way galaxy, a subtle force we never feel, can stir this cloud of icy sleepers. When such a nudge occurs, it dislodges one of these frozen worlds, tipping it from its stable orbit. It then begins a long, slow fall sunward, a journey that can take thousands, even millions of years. This is the birth of a long-period comet. The threat these objects pose is unique and deeply unsettling. Unlike asteroids, which mostly orbit in a predictable belt between Mars and Jupiter, long-period comets can approach from any direction in the sky. Their orbits are not neat, flat ellipses, but are often wildly tilted, diving in from above or below the solar system's plane. Their immense orbital periods mean they are visitors from the deepest, darkest cold, and many are first-time travelers to the inner solar system, making their behavior completely unpredictable. They are cosmic strangers, and by the time we see them, they are often already closing in. As a comet falls toward the sun, it begins to warm. Its ancient ices, frozen for eons, transform directly into gas, erupting from the nucleus and carrying dust with them. This creates the comet's magnificent tail, a beacon that can stretch for millions of miles. But this beautiful display marks an object of terrifying potential. The nucleus of a long-period comet can be dozens of miles across, a mountain of ice and rock traveling at speeds exceeding 150,000 miles per hour. An impact with Earth would release energy millions of times greater than the most powerful nuclear weapon ever built. It would be an extinction-level event, a global firestorm followed by an impact winter that could last for decades, collapsing the biosphere. The real terror lies in the warning, or rather, the lack of one. Because they come from such vast distances and on such strange paths, we might only have months or perhaps just a year or two to see one coming. Our survey telescopes are constantly scanning the sky, but they are looking for needles in a cosmic haystack the size of the inner solar system. A dark, inbound comet could easily slip through the gaps, its icy nucleus only becoming visible when it was already too close for any meaningful deflection effort. Every streak of light in the night sky from a random meteor shower is a tiny, harmless reminder of the countless larger projectiles still drifting in that distant, silent cloud, each one a potential key to our undoing, waiting only for a star to pass by in the night. The silent, ancient threat of a comet from the Oort cloud is a danger from the distant reaches of space, but a more intimate and unsettling possibility hides in the very nature of reality itself. What if the universe is not a fundamental reality, but a sophisticated fabrication? This is the simulation hypothesis, a theory proposing that everything we perceive, from the farthest galaxy to our most personal thoughts, is nothing more than an elaborate computer simulation run by a civilization of post-human beings, entities so advanced their technology is indistinguishable from nature itself. The foundations of this idea rest on a few simple, logical steps. First, assume that a civilization eventually reaches a technological level capable of creating simulations of conscious beings. Second, assume that such a civilization would have the curiosity or the processing power to run not just one, but countless such simulations, perhaps for research, entertainment, or historical preservation. If both of these are true, then the number of simulated realities would vastly outnumber the one base reality. Statistically, the odds that we are living in that one original universe become astronomically small. We are almost certainly living inside one of the simulations. The evidence, some argue, might be hidden in the very code of our universe. At the smallest scales, the quantum level, reality behaves in ways that seem oddly digital. Particles pop in and out of existence, and some properties appear to have a finite resolution, like the pixels on a screen. The speed of light itself could be seen as a processing limit, a maximum rendering speed for the cosmic computer. Why do distant stars fade into a darkness we cannot see beyond? Perhaps that is the edge of the render distance, the point where the simulation stops calculating details to conserve processing power. The philosophical implications of this are staggering and deeply terrifying. Every memory you hold dear, every person you have ever loved, every fear that has ever gripped your heart could be a complex but ultimately meaningless data structure. Your sense of self, your consciousness, would be an emergent property of an algorithm, a ghost in a machine you did not know was a machine. Your entire life, with all its struggles and triumphs, could be a brief subroutine in a program running on some unimaginable computer in a reality you can never access. The ultimate horror lies in the lack of control. The simulators, whoever or whatever they are, could decide to shut down the simulation at any moment for any reason. A power outage, a system upgrade, or simple boredom could erase our entire universe in an instant. There would be no warning, no appeal, and no memory of what was lost. One moment existence, the next absolute and final nullity. This is not a threat from space, but a flaw in the very ground of being, a silent question mark hanging over every single moment of our lives. Are we the creators, or are we the created, living out a script written by gods we will never know? Our journey through the cosmos has revealed monsters and cataclysms, but the final and most profound terror is not a thing we can name. It is the vast, uncharted ocean of our own ignorance. For every cosmic mystery we have solved, a dozen more have emerged from the shadows, each more baffling than the last. The very foundations of our understanding are built on sand. The twin pillars of modern physics, the Standard Model and general relativity, are brilliant and powerful, yet they are fundamentally incomplete. They cannot explain the ghostly pull of dark energy or the singular moment of the Big Bang. They offer no insight into what, if anything, came before that first instant, or what truly lies beyond the observable edge of our universe. We are using a map that shows only a small island in an infinite sea, and we have no idea what creatures swim in the depths below. The true horror is the limitless potential of the unknown. What if the cosmos contains phenomena that defy not just our laws, but our very capacity for thought? Could there be entities or forces so alien that our brains, evolved to hunt on an African savanna, are simply not wired to perceive or comprehend them? They would be like a fourth dimension to a flatlander, an impossible concept manifesting in ways we would dismiss as natural disaster or random chance. To confront this, we need only look at a single, humbling image. The Hubble Extreme Deep Field is a portrait of profound silence. Astronomers pointed the telescope at what seemed to be an empty patch of sky, a void between the stars. After collecting light for countless hours, they revealed a scene that forever changes your perspective. That tiny, dark speck was not empty. It was filled with thousands of galaxies, each a swirling metropolis of billions of stars, each star potentially orbited by worlds. In that one image, you are seeing a universe so crowded, so vast, it defies every human scale. And every one of those 10,000 pinpricks of light is not just a place of wonder. It is a hiding place. Within any one of those galaxies, a terror beyond our current imagination could be lurking, a fundamental truth about reality that would shatter our understanding of existence itself. The darkness is not empty. It is full of questions we have not yet learned to ask and answers we might not be prepared to hear. We have traveled from the dark wanderers at our doorstep to the final, silent end of all things. These 25 terrors paint a universe of breathtaking beauty and profound peril, a cosmos that can create life in one moment and erase it in the next. Our journey reveals a reality where our existence is balanced on a razor's edge, threatened by solar fury from our own star, by icy comets from the frozen dark, and by the slow, inevitable decay of the universe itself. This knowledge is not meant to paralyze us with fear, but to grant us a powerful perspective. It highlights the incredible fragility of our pale blue dot and the astonishing fact that we are here at all, conscious and able to contemplate these vast mysteries. Every terrifying discovery, from the ghostly pull of dark matter to the predatory silence of the Fermi Paradox, deepens our appreciation for the delicate thread of our own story. So we turn this question over to you. Which of these cosmic threats sent the deepest chill down your spine? Was it the thought of a rogue black hole drifting unseen through our solar system, or the silent, one-time whisper of the wow signal? Share your thoughts in the comments below, and if you found this journey through the dark both frightening and fascinating, subscribe for more deep dives into the mysteries of space. Let's continue turning our fears into a relentless curiosity for the great unknown.